and good evening, team. Alright, let's begin our meeting. We have received a complaint from the quality department regarding the last batch of plastic cups. The final product dimensions didn't meet the required specifications, so we are here to determine the root cause and discuss how to solve it effectively.
Okay, so based on our inspection report, the plastic cup produced yesterday were about 2 millimeters shorter than the standard size, which is 95 millimeter height, and the wall thickness was uneven. After checking the material batch, mold design and forming temperature, we confirmed that all the parameters were normal. The only concern recorded was from Thermoforming Machine TF-220, which showed unstable performance during operation.
Yes, Luqman. I also received similar feedback from the operator. They reported that machine TF-220 was vibrating excessively and making a louder sound compared to usual. Because of that, the mold did not close properly, leading to uneven pressure when forming the cup. They explained why the product came out slightly smaller and thinner. So the main issue we are dealing with today are, the first one, the product dimension is not following the standard specification, and the second one, thermoforming machine TF-220 is experiencing abnormal vibration.
So teams, I already checked the machine this morning and took some vibration readings. The overall vibration level was around 6.6 mm per second RMS, which is higher than the normal safe limits of 4.5 mm per second. The vibration pattern suggests soft misalignment and possible bearing wear. Both could cause the machine to shake during the forming process. If this continues, the vibrations may worsen and eventually cause more serious damage to the motor or coupling.
That's quite concerning. So, the vibration is likely the main cause that affected the forming accuracy and product dimension. EMIN, do you think we can confirm whether the issue is more to bearing wear or alignment problem?
Yes, Hakimi. From the readings, both are likely involved. The vibration frequency shows imbalance and alignment errors. We will need to open the motor housing and check the main bearing, coupling and motor alignment to confirm. So, I would also suggest we perform vibration balancing once we identify the faulty parts to ensure the rotation is stable afterward.
Oh, that makes sense. If the vibration truly comes from the mechanical side, it aligns with what we saw in a production line, which is smaller cup size and inconsistent wall thickness. So our quality issue directly links back to the vibration problem.
Okay, thank you, Luqman. To move forward, I propose that we can schedule a short time downtime for machine TF-220 to conduct the full inspection. We can do it during the evening shift to minimize production loss. Meanwhile, we will temporarily move production to machine TF-221 to maintain our daily output target.
That's good idea, Fahim. And after inspections, once we know the defective part, we can proceed with alignment corrections and balancing for long-term improvement. I also recommend installing vibration monitoring sensors on all thermoforming machines that will help us detect early signs before vibration becomes severe.
I agree. Predictive monitoring will definitely help. Fahim, please also ensure that operators are briefed to report any unusual vibration or noise immediately. Even small changes can indicate early mechanical problems.
Yes, I will prepare a machine condition checklist for operator to fill out at the start and end of each shift. It will include vibration field, sound, temperature, and product quality. This will make early reporting easier.
Okay, so from my side, which is quality department side, we will continue to monitor product dimension from each production line and send weekly data to the maintenance. If we notice any size different again, we will alert your team immediately.
That's good system, Luqman. Once we complete the inspection and corrections, I will recheck the vibration level. It should return below 4.0 mm per second RMS. We will record the new data as a baseline for future comparison.
Alright, before we wrap this up, let's summarize the key points and agreed actions. First, problem 1. Product dimension smaller than the standard. Problem 2. High vibration detected on thermoforming machine TF-220. So the action plan is to conduct full inspection on TF-220, focusing on bearing, coupling and alignment. Perform vibration balancing and alignment correction after confirmation. Shift production temporarily to TF-221. Introduce operator machine. Checklist for yearly detection. Install vibration sensors for continuous monitoring. And strengthen data communication between quality, production and maintenance department.
Oh, that's clear plan, Hakimi. Once the inspection and balancing are complete, we will validate the next production batch and confirm that the dimensions are back to the standard.
Yes, and I will coordinate the production to ensure that downtime is properly scheduled tonight. We will also brief the operator before the next shift begins.
So after that, I will complete the vibration readings before and after corrections to include in the report, so we can track the improvement.
Excellent team! Thank you everyone for your input and cooperation. Let's proceed according to the action plan and make sure we restore normal operation as soon as possible. Once the vibration issue is resolved and the product quality is stabilized, we'll hold a short follow-up meeting to review the final results. If there is nothing to add, Luqman? Fahim?
No.
Emin?
No.
If there is nothing else to add, this meeting is officially closed. Thank you everyone again for your time and contribution.
Welcome. Okay.
Okay.